Guys, good morning. Just going to go through this lesson, talking about graphs and analysis of log functions. Closely really relates to exponential functions because one of the first things that first paragraph talks about is the inverse of a exponential function is a logarithmic function, and then the same is true. The inverse of a logarithmic function is an exponential function. So this first page kind of really just walks us through graphing and exponential equations. If I look here, this problem right here, just kind of going back to exponential functions when we were talking about graphing them. I know that there's a horizontal asymptote at 2 because that's my constant. The negative out front tells me that it's going to be below the horizontal asymptote. And the x plus 3 means I'm moving it to the left 3 units. So over here on the left-hand side, that's 2 to the x. That's kind of our parent function. That's what it would look like if it was just 2 to the x and all of my ordered pairs. And then based on what I have in my equation, this would be the rule for basically f of x with all of my transformations that we had. We had a x-axis reflection moving it left 3 and up 2 units for the horizontal asymptote. So I'm just plugging in -2 and 1/4 into our rule, and this is where these ordered pairs come from. And then I would have my graph there. So back to inverses real quick. How do you find the inverse of a function? Basically, if you just have a graph, the easiest way to do that is just switch the domain and range. So the first thing that you'll notice here, here I had a horizontal asymptote, and now when I look at my inverse, I now have a vertical asymptote at x equals 2, and then all of my ordered pairs are just getting flipped. So this graph right here represents the inverse of that exponential function. So algebraically, how we find the inverse of a function, we have to go back and we have to remember there's really 3 steps that we have to do. The first thing is we have to switch x and y that's in the equation. So I'm basically taking out f of x, I'm putting in y, and then I'm going to switch x and y. And then I'm just going to resolve the equation for y. And then at the end, you're just going to replace y with your inverse notation. So if I look at this one right here, this exponential function, I take out f of x, I write y, and then I switch x and y. That's the first step. So that's where we're at right here. We switch x and y. So now we are going through, and I'm basically solving that equation for y, which is going to have to use logarithms. We kind of talked about, how do I solve exponential equations algebraically, is I have to, first thing is to isolate the exponential expression on one side of your equation first. So that's why we have, -2 from both sides. I subtracted 2 from both sides. Then we divide both sides by -1. So that's why it turns into -x plus 2. And at that point, now I have my exponential equation isolated by itself. So now what I would need to do is I need to logarithmitate both sides of my equation. So I'm going to logarithmitate both sides of my equation using the base of my exponential expression. Hence why I have log base 2 of both sides, because that is the base of my exponential expression. And the reason why I want to do that is because anytime I have log base of a number and my argument on the inside is the same number, those two things will cancel out, and I'm just left with this exponent, which is y plus 3. And then the last thing I would have to do to get y by itself is subtract 3. They write it as -3 plus your log base 2 of -x plus 2, instead of writing it as log base 2 of -x plus 2, and then -3. The reason why they do that is because sometimes I've seen kids that'll do this, log base 2 of, they'll write -x plus 2 and then like -3. Where, yeah, but the problem is if I were to look at that, I would maybe think that that's all connected together because I did not end my parentheses. So I can still write it as -3, but I just need to make sure that I write parentheses after the, the -x plus 2 really needs to be isolated in parentheses. Or you can write -3 plus, it's the same thing. And that is my inverse of that exponential equation. I end up with a logarithm. So going down here below, I got 3 questions, 3 examples that are basically just going through the same thing. Hold on one second. I got to let my dog inside. All right, sorry about that. So where were we? Looking at these 3 examples. All 3 of these examples are basically the same thing. You just have to remember the first step, switch x and y, solve for y, which means that we have to isolate the exponential expression by itself, and then we're going to logarithmic both sides. Notice here on number 2, we isolated e to the y plus 2 by itself right here. So then if I'm going to logarithmic both sides of my equation, my base of that exponential expression is e. So when I take the log of both sides, I would be taking the log base e, which is the natural logarithm. All right, so moving down, those are just some examples. This page right here, if I can rotate this, there we go, is basically talking about how do you find the domain and the range of a exponential function, and then basically what would that mean for the inverse, and the inverse being a logarithmic function. So I'm going to scroll down here to this next page. Let me rotate it back. These first 3 statements are really kind of the big things from the rest of this. So find the following characteristics of a log function given the equation of the function. So if you know the equation of a logarithm, can you find the vertical asymptote? Do you know what the domain is? And then how do you determine what the range is? So these 3 things are important. So the first thing is, if I think back to exponential equations have a horizontal asymptote. The domain is always negative infinity to positive infinity. And then the range is always basically going to be, all right, is it above or below the horizontal asymptote? So if I think, all right, a logarithm is the inverse of that. Now, instead of a horizontal asymptote, we have a vertical asymptote. So how do I find the vertical asymptote of a logarithmic function? You set the argument, whatever it is, inside of your logarithm equal to 0 and solve for x. How do you determine the domain? Well, this is the exact opposite of exponential equation. So basically how we found the range of an exponential equation is how you find the domain of a logarithmic function. It just kind of depends. Is your function going to be to the right or to the left of your vertical asymptote? So to determine that, you set the argument greater than 0 and then solve for x. And that's going to tell you your domain. So then at that point, you know it's to the right or to the left. The range is the same thing as the domain of the exponential expression. So the range is always going to be negative infinity to positive infinity no matter what. So then I walk you through an example here. So here I have a logarithmic equation. And then I have another one over here. So first thing, since it's a logarithm, it's going to have a vertical asymptote. How do you find the vertical asymptote? You set the argument, which is 2 minus x, equal to 0, and solve. So I know that this graph has a vertical asymptote at x equals 2. Now the domain, I set 2 minus x greater than 0. I'm setting the argument greater than 0 and then solving. And I just have to make sure I divide by a negative right here. So I end up with flipping my sign. X is less than 2. That's inequality notation. So interval notation, we're looking at negative infinity to positive 2. And my range is negative infinity to positive infinity. And then this last question here, does the graph lie to the left or to the right? Well, what's the domain say? The domain says, all right, it's from negative infinity to our vertical asymptote. So that would be to the left. Over here is just another example. So I'm going to go ahead and move on. But it's basically the same stuff. Vertical asymptote, set the argument equal to 0, domain, set the argument greater than 0 and solve, and the range is always negative infinity, positive infinity. All right, so here we got a table of values. We'll leave it up there. So a table of values, and I know that f of x is equal to e to the x minus 2 minus 3. So we're dealing with an exponential function. A, what is the equation of the horizontal asymptote? Well, I know it's negative 3 because really of two different ways. They're listing here because of our end behavior as x approaches negative infinity, our graph's going towards negative 3. Negative 2, we're getting closer to negative 3. I also know it's negative 3 because that's the constant in my equation. B, is the graph of f of x above or below the horizontal asymptote? Well, if I look at my function values and compare it to negative 3, my y values are all above it. Okay, so when the inverse function is graphed, will the graph be to the right or to the left? Well, since f of x is above its horizontal asymptote, then that means the graph of the inverse would be to the right of the vertical asymptote. C, what is the equation of the vertical asymptote? It would have to be x equals 3 because y equals 3 was the equation of the horizontal asymptote. And then the last thing here is we really have D, well, not last thing, D, just the domain and range of the function and its inverse. So I know that my function, f of x, is an exponential function, so the domain is negative infinity to positive infinity, and my range is above the horizontal asymptote, so it's negative 3 to infinity. So my inverse is going to be those two things, but just flipped. E, find the equation of the inverse function. So this is basically what we just did on the last page. I need to isolate. First thing, switch x and y. Then I need to isolate our exponential equation so I can logarithmic both sides. And I end up with my inverse function is 2 plus the natural log of x plus 3. And then basically the graph, we know where the vertical asymptote is going to be. And you don't really have to think about what it looks like. All you would need to do is take those ordered pairs that are in your table and then flip them and then regraph it, and then that's your inverse. Because you know that the easiest way to graph the inverse is just to switch the domain and range of the original function. This next page here, our last page of the notes today, they give you another exponential function. It's negative 2 to the x plus 2 power plus 3. They give you some table of values. So A, what is the equation of your horizontal asymptote? You know that it's equal to 3 because of your end behavior. As x approaches negative infinity, it's going towards 3. I also know it's 3 because that's my constant in my equation. B, is the graph above or below the horizontal asymptote? So when I go to look at my function values, all the y values are below 3. So I know that my function is going to be below f of x. And then talking about the inverse, I know that the inverse is going to be to the left of the vertical asymptote because our original function was below. Now, C, what is the equation of the vertical asymptote? I know it's x equals 3 because y equals 3 was the equation of the horizontal asymptote. I would go through the domain and range of f of x, and then for my inverse, I would flip it. And then lastly, here again, we are just finding the equation of the inverse function. So first thing I'm going to have to do is switch x and y, isolate the exponential expression by itself. So subtract 3 from both sides, divide by negative 1. So here I have my exponential expression that's now isolated. Now I'd have to logarithmic both sides. So my base of my exponential expression is 2. So when I take the log of both sides, my base needs to be 2, which it is. Over here on the right, these two things would cancel out, and we're just left with y plus 2. And the last thing I'm going to have to do is just subtract 2 from both sides. And then F says to graph. So draw the vertical asymptote, and then just switch all the domain and range, all of those ordered pairs in your table, and then you have the graph of your inverse. All right. So that is the end of the notes. Kind of got through that a little quick. Like I said before, I don't want to sit here and talk about notes for 40 minutes. I mean, you guys can rewind and watch stuff pretty quickly if you need to. So let's recap what we're going to have the rest of the week. You guys will need to do, I believe it's day 59, or it's a day of homework. Day 59 homework and free response number 32. And then just keep in mind that I will be posting a logarithmic test on Friday, all multiple choice again. And we will go from there. Try to have these 2 days of homework in by Friday. So that way I can get them graded, get them into Power School. And then we'll take that test on Friday, and then we'll go from there. Sounds like, based on DeWine's announcement yesterday, that we'll be doing online school for the rest of the year. Hopefully we'll be hearing from the school pretty soon about what exactly that will look like. I really have no answers for you at this point. Otherwise, I hope you guys are doing well, staying safe, and be looking for the test on Friday.